Okay, Bismillahirrahmanirrahim. For today, we learn first order logic. Okay, this one I think you have learned in discrete structure or discrete math. For first order logic, basically you talk more about the logic, logic, and then about the quantifier. Okay, and also you look into the predicate calculus. Basically, first order logic, also known as predicate logic. Mm. Okay, also known as predicate logic. Okay, and then the other name for predicate logic is quantificational logic and first order predicate calculus. It's a collection of formal system used in mathematics, philosophy, linguistic, and also computer science. But in here we are using uh, in a in a formal methods. Okay. Okay, for the content, it's more on representation because we look into the formal methods. We look more about the deductive, and then we look into the syntax and semantic of first order logic, the application, how you want to apply the first order logic, and then the knowledge engineering in first order logic applications. Okay, by the definition, also known as a predicate logic, quantificational logic, and first order logic predicate, okay, is a collection of a formal system and being used in a lot of application, especially in mathematics, philosophy, linguistic, and computer sciences. And then first order logic uses a quantified variable. You need to quantify a variable. For example, you can have universal quantification and existential universal and existential, okay, quantification over non-logic logical object and allows the use of the sentences that contain variables. Okay, do you have any question so far? Okay. Okay, for the quantified variable, sometimes we call it as a quantifier. Variable that you are quantify, you are measured are called bound or unbound variables, and those not quantified are called free variables. Okay, we have a quantified variable, either free or bounded variables. Okay, for quantified, okay, expression. Okay, and you want to determine whether some or all of the item in the sequence meet the particular condition. For example, if you want to know whether any of the item in the order of from the accessories department, you can use the expression. You can use the expression, okay, to look into the uh, quantifier. Okay, for logic, so that rather than proposition, okay, you can have Socrates is a man. One can have expression in the form that there exists X such that X is Socrates and X is a man. This one is quantification in a logic. Okay, where there exists is a quantifier, and while x is a variable. Okay, we must know the proposition. Okay, the proposition you have learned in a discrete structure. Okay, proposition basically is a statement or assertion that express a judgment or opinion. Okay, this distinguishes or differentiate it from propositional logic, which does not use the quantifier or relation. Basically, in pre-order first order logic, we use the relation. In this sense, propositional logic is the foundation or fundamental of first order logic. Okay, okay, it does not use quantifier or relation. Okay, propositional logic is foundation of first order logic. Okay, we have two names here. First, we can name it as a predicate logic, and secondly, a first order predicate calculus lah. Okay, it is more or like Boolean. It is more powerful than a propositional Boolean logic, and then it is expressive power than a propositional logic, so that we can analyze by the rules, and you can separate the premises. Okay, for example, uh, which other square are breezy or pizza? Okay, and then it also have the characterization of to allow for the facts, object, and also relation. By the programming terms, it allows classes, function, and also the variables. This one for the programming terms. Okay, we have advantages and disadvantages of professional logic. Okay, professional logic is very declarative. Declarative, which means that you need to describe and then be able to define what is the facts. Okay, you need to deduce the statement. And then professional logic allows for partial disjunctive negated information. Unlike most of data structure and databases. Okay, this one. Okay, negated information. Okay, and then professional logic is compositional. The meaning of B11 conjunction on and P12 is derived from the meaning of B11 and P12. Okay, compositional. Okay, compositional mean that you need to compound the statement. Okay, need to compound the statement. You need to relate the uh, various of elements. For here, it is a meaning you need to compound the two proportional logic statement. And then the fourth one is meaning of proportional logic is the content in context independent. Unlike the natural languages that we defined in chapter 3, where the meaning depend on the context. Okay, the meaning is depend on the context, what you want to achieve. The other way is depend on the context is depending on the objective that you want to achieve. Okay, and then for the professional logic also have very limited expressive power unlike the natural languages. Okay, for example, cannot say pigs because the breeze in adjacent square except by writing one sentence for each square. Okay, they have limited potential. Okay, if you compare with the natural languages, okay, natural languages, you cannot say incomplete. Okay, this one you cannot say incomplete because you need to have some context. Okay, you have to have some context to explaining or describing the logic. Okay, for the pros of first order logic, assume that the world content of three uh, domains. Okay. Okay, the first one is the object. Secondly is for the object, they have the relations, and then thirdly they have the functions. Okay, for the object example, we have people. Okay, like students. Okay, we have workers and so on, and then we have houses, numbers, theories, colors, football games, wars, centuries, and so on. And then for the object itself, it must contain relationships. Okay, relation such as red. Okay, people have the red, blue eye, and so on. And then houses has bigger parts. Okay, and then has colors and so on. And then for two of the entities, they have a function. Okay, function father of, best friend, third quarter of. You characterize the relation. Okay, we have okay. Okay, this one is the object. Okay, we have a relation here, and then we have function here, whereby the relation, whereby the function is a subset of a relation, and a relation is a subset of the object. Okay. Okay. Basically, when you look logic in general, you can have the sum of the ideas that you have learned professional logic for the facts, first order logic, okay, temporal logic, probability theory, and fuzzy logic. Okay, for the language itself, depending on the ontological commitment and then epistemological commitment. Okay, they have two different views here, ontological and epistemological. For ontological, for the professional logic, is based on facts. Okay, for the epistemological, based on the true or false or unknown. This one is based on the domain. Okay. Okay, and then for the first order logic, based on the facts, object, relations, and then for the epistemological, is also based same as professional logic. We have true or false or unknown. Okay, and then we have temporal logic. Okay, for the ontological, mean the you need to uh, study the existence or the condition for the ontological. Basically showing the relation between the concept and categories in the subject area or domain of the problems for ontological. Okay, for epistemological, it's more on the relating the theory to the knowledge. Either the knowledge is either true or false, especially with the regard of the methods, how you want to relate the method, validity, and also the scope. And then the distinction between justified belief and opinion. Okay, this one you can have either the true or false. Okay, what epistemological foundation is there for such uh, the artificial discrimination, for example? Okay, and then we have a probability theory. Ontological is based on the facts, and then Etymological is based on the degree of the belief. Is the member of 0 and 1. If 0 is false and 1 is true, true and false. Okay. Okay, then we have fuzzy logic. Okay, and then for the ontological, we have degree of truth. And then for the epistemological, it's based on the interval values. Lah. Okay. Basically, for the fuzzy logic application, you can have basically in the rice cooker. Rice cooker is many valued logic in which true value variable may be real number between 0 and 1. This one is the degree depending on the degree of truth. It is employed to handle the concept of partial truth, where the truth value may be ranged between completely true or completely false. This one for fuzzy logic. And then we have a syntax of first order logic. We have some of the domain here. First one is the constant, second predicate, function, variable, connective, equality, and quantifier. We have seven. Okay, we look one by one. Okay, we look one by one. Okay, for the constant. Okay, constant in the first order logic is a set of five. Basically, is a universal, uh, and basically is a set of sentence is satisfied by more than one interpretation. Okay, by more than one interpretation. For example, you can have King John, number two, and so on. This one is the set of sentences is satisfied by more than one interpretation. Constant. Set of sentences. Okay, is it okay, guys? And then we have a predicate. A predicate in first order logic is a symbol which represent a property or relation. Okay, this one is basically all in the first order logic for the predicates. Okay, predicate basically a symbol. Symbol which represent property or relationship. Okay, for example, what is the predicate in the first order logic. For example, we have man is a mortal, and let bx be a variable. Then mx is an atomic formula, meaning x is a mortal. So as we know, a predicate is expression of one or more variable can be defined on some domain. Okay. Predicate is you need to define it. Okay, this one you need to define in some variable, some domain. Okay, for example, m, okay, m is equal to man is mortal. Okay, and then you can mx, okay, whereby x, okay, okay, this one is for predicate. Okay, for example, here we have brothers, we have greater than, less than, or so on. Okay, first we have I have explaining the constant. Secondly, we have explaining predicate, and thirdly, we go for the functions. Okay, this one is for the first order logic. First order logic for the functions. Okay, for the function, you need to declare what is the consequences or equivalences. For example, we have square root, we have left arm off. Okay, you need to have the uh, consequences or equivalences. Okay, for the function. Okay, basically for the function is the identity of the symbols. Okay, and then we have a variable. Okay, variables of first order logic. Basically, for the first order logic, uses the quantified variable of a non-logical object and allows to the use of sentences that contain variable. So that rather than propositions such as Socrates is the man, one can have expression in the form that there exists X such that X is Socrates and X is a man. Okay, we can use X where the exist is the quantifier. Okay, we use the variable, okay, over the non-logical object. Okay, and then we replacing the sentences. For example, Socrates is the man. Is a man. You can express such that there exists X, such that X is Socrates and X is a man. Okay, you quantify. You quantify. Okay, for the variable. And then you have a connective. Connective are used to combine the atom into a formula in the first order logic. For example, you have implication, you have double implication, and so on. Okay, you have disjunction, you have conjunction. Okay, this one is connective. okay, used to combine the atom into formula. Okay, atomic sentences. Okay, later we see this one. Okay, and then we have equalities. Okay, for the equality of first order logic, okay, interpreted as a real equality relation between members of the domain of discourse, okay, such that the two given member are the same member. Okay, you need to associate the equality symbol as a primitive logical symbol. For example, here you have equal sign. Equal sign. Okay, this one is for the equality. Okay, you need to interpret the real equality relation between members. Okay, here real equality relation between members. Okay, that one is number six is equality, and then lastly we have quantifier. Okay, quantifier of first order logic, also known. Okay, quantifier in first order logic is a language element which generate a quantification. And then quantification, you need to quantify specific. Okay, for example, you have for some, for all. Okay. Okay, when you use the quantifiers from the different type, the order is matters lah. Okay, for example, when order matters, the first quantifier quantify the subject of the sentence, and then the other quantifier quantify the object of the verb. For example, let our universe of discourse be human being, and let LXY mean X love Y. Okay, okay, fun. Okay, quantifier. The order of quantifier is matter because the first quantifier quantify the object of the sentence, and the other quantifier quantify the object of the verb. For example, we have you for universal discourse is a human being. You is human being. Okay, and then we have let uh, L X Y. Okay, means that X love Y. Okay, this one is a quantifier. Okay, later we see in detail. Okay, for quantifier, and then a component of first order logic. we have term constant, example rate, a function of constant. Okay, function of constant mean you need to have the function inside the constant. Okay, for example, we have colors, we have a block one, and then we have atomic sentences that predicate a relating object is no variables. For example, we have John is a brother of Richard, and then we have uh, Father John and Mother John are married. Okay, we have atomic sentences. Okay, for the atomic sentences, are the most basic sentence of first order logic. These sentences are being formed from a predicate symbol followed by parenthesis, which a sequence of the term. Okay. Okay. For another example, for atomic proposition, phi is a prime and uh, program will terminate. And then propositional formula are constructed from atomic proposition by using the logical connective. Okay, this one is atomic sentences, and then we have complex sentences. We combine the atomic sentences and logical connective. For example, here we have John, brother of Richard, and Uh, John is a brother. Brother father is not. Okay, we put the negation here. Okay, we negate. Okay, we negate the logical connective. Okay, okay, logical connective is used to combine the atom into a formula. Okay, by using the conjunction. Okay, here we have a conjunction. Okay, okay, conjunction or disjunction. For here, for the complex sentence, we use the conjunction. Okay, this one complex sentences. Okay, we combine two atomic sentences and logical connective. Okay, this one just for a reminder. Okay, we have a component of first order logic. Basically, we have a quantifier for all. Okay, for all, and then we have existential quantifier that exists. Okay, for the each quantifier, define a variable in the domain of discourse for a duration of the following expression. For all, expression is true for every possible value of the variables, and then existential quantifier that exists, the expression is true for at least one value of the variable. Okay, this one is a logical component that you need to understand. Okay, so far, do you have any question for the quantifiers? Okay, basically for the first order logic contains only two quantifiers. Okay, quantifier are word expression of phrases that indicate the number of the element that a statement pertains to lah. In mathematical, there are two quantifiers for all or there exists. Okay, in general, quantification is performed on the formula of predicate logic called WFF. Well, form a formula. We can use x equal to 1 or px by using quantifier on the variable. Okay. Okay, and then we have a true in the first order logic. Sentences are true with the respect to model and also for the interpretation. Among the content is greater than or equal to one object is a domain element and relation among them. So. And then interpretation specify some of the references. For example, we have constant symbol. We name it as a object. And then predicate symbol for the relation and function symbol for functional relationship. Okay, and then an atomic sentences predicate. For example, we have term one until term n is true if and only if the object referred by the term one, term two, and so on are relation referred to by the predicates. This one is the truth value. It is must contain more than one object and must have the must have the relationship among them. This one is truth in the first order logic. Okay, do you have any question? Okay, for the interpretation, the symbol of a language. Okay, some of them we interpret as a constant symbol. Okay, some of them we interpret as a predicate symbol, and some of them we interpret as a function symbol. So. Okay, for example, we have two unary predicate symbol, fancy and tall. Okay, we can have for all. Okay, and then we have a fancy. Okay, we want to infer this one either true or false. The answer, of course, is that we don't know, we don't have enough information to say. There is no obvious meaning to predicate fancy or tall. Okay, we don't have any evidences for predicate fancy or tall. At least not when we apply them to natural numbers. To make sense of the sentences, we need to know which number are fancy and which one are tall. We need to clarify, okay, for the sentence. And then perhaps multiply by 10 are fancy and even number are tall. In this case, the formula is true since the every multiple of 10 is even. Prime number are fancy and the odd numbers are tall. Okay, then the formula is false since 2 is fancy but not tall. Okay, because of that, we can call each of these description as interpretation of the predicate symbol fancy and tall in the domain of n. Okay. Uh, Okay, this one we can conclude that we have for all x and then fancy x, tall x is true. Okay, and then after we interpret, we can define this one as a false because the interpretation is unclear. Formally, interpretation of unary predicate P in the domain set of element D, which is P is equal to true. Okay, it is also significant or important to emphasize the difference between a predicate symbol or function symbol or constant symbol. We need to distinguish either it is constant, predicate, or function symbol, and the semantic predicate it is a function or object to which it is interpreted. Uh, the former is a symbol related to other symbol and has no meaning on its own, whereby the prime is the predicate symbol. Okay, sometimes we can interpret a language in a particular domain. It is useful to implicitly introduce new constant symbol into the language to denote the element of the domains. Okay, sometimes we introduce a constant symbol and sometimes we introduce the predicate symbols to to show some of the relationships. Okay, and then for the truth in the first order logic. Okay, we need to interpret. We need to interpret the predicate or the relation applied to some terms. First, uh, first procedure, we first interpret the term as an object in the domain and then see if the interpretation of the relation symbol is true or false for that domain. Uh, okay, this one is for the constant, predicate, and function symbol. Okay, so far, do you have any question? You need to specify the domain of the discourse first, and then try to apply and interpret the the sentence either it is a constant, a predicate, or functions. Okay. Okay. For example, in here for the fancy. Okay. For the fancy, it is false because we don't know the domain of discourse. Okay, for example, here we have a person, we have a crown, and then we have person king, and then we have relationships. Okay, okay, brothers. R is brothers of J, and J is brothers of R. Okay, for the universal quantification, here we have uh, syntax or good practices for all x. P is true in the model M if and only if P with the X being possible object in the model. Okay, it is equivalent to conjunction of the instantiation of P because it is an object. Okay, we have a mic, KSU at mic is equal implies the mic, smart mic is a smart end. Okay, we use some of the instantiation of the object. This one is you need to clarify the object. Okay, it is a common mistake to be avoided. Okay, it is typically is the main connective with uh, for all quantifier. Okay, basically, we go by the implication. Okay, and then a common mistake using the conjunction when the main connective with the quantifier for all. For example, here, okay, we use the conjunction here. It must be used the implication, the main connectivity, the main compounding factor. Okay, and then for the existential quantification, uh, P is true in the model M if and only if P with X being at least one possible object in the model. Okay. Okay. Typically, when you use the for some, okay, for some of you using the implication symbol, implies symbol as the main connective with there exists or for some lah. Okay, this one is error. Okay, okay. Try to avoid okay, because this one is not it's not common to have a mistake for the connectivity for the quantification. Okay, for example, okay, everyone likes McDonald. Okay, uh, everyone X okay likes McDonald. X and McDonald. Okay. Okay, then someone likes McDonald. Okay, all children likes McDonald. Use the implication. Okay, and then everyone's like McDonald unless they are allergic to it. Okay, we can have two. Okay, either one. Okay, we have everyone likes McDonald's. Okay, or allergic to McDonald. And then we have also you can have the negation. Negation implies X like McDonald's. Okay. Okay, you can have a statement like this.